Here we go. We are talking about 7.2, length of daylight. This is page number 53 in your booklet. Today, as I record this, is the first day of spring. You may have noticed that during the winter, days are shorter, and during the summer, days are longer. Well, we're going to talk about how much longer days are during the summer, and do the length of summer days change depending on the latitude. If you remember, latitude is how far north or south you are from the equator. We're going to talk about 3 cities in our booklet here, and then you're going to do 3 cities on your own for a project. The first city we're actually talking about today is Houston, Texas, approximately 30 degrees north. And then in the next couple of videos, we'll talk about Philly and Porto Alegre in Brazil. So the data we have here is talking about the data in the table says activity estimates of the length of daylight throughout the year. This all data was given to us. But to start us off, which city would you expect to have more daylight during the summer, Houston or Philadelphia, and why? I'm going to post a discussion on Canvas that you guys are used to doing now to look at that. First things first here, we have the date here. Oops. We have the date. We're talking about the first of the month every month, the corresponding day number to those. And then we have the hours and minutes of daylight. So if you notice 10 hours in January, so there's less hours, less than half the day is daylight. And that converts to 617 minutes. Down here it says, how was that length converted from hours and minutes to just minutes? And that is up here. So we took the 10 hours and the 17 minutes as the 1017, and we took that 10 hours and multiplied it by 60 because there's 60 minutes in an hour, and added 17 to that. So that'd be 600 plus 17 gives us 617 minutes. What we want to do is we want to kind of see what this looks like. So I have all of my data typed in to my calculator into L1 and L2. I have my day number typed into L1, my length of daylight in minutes typed into L2. And I'm going to go make sure that my scatter plot is turned on. So I hit second y equals, make sure the plot is on. So you have to hit enter here, and it might start off as off, make sure it's on. And then we want to go zoom 9. I'm going to clear out my y equals, and we hit zoom 9, and that shows us our data. Nice little curve there. It goes up and it goes down, and it'll repeat this every year. It'll go up and go down. The final thing we're doing today in this video is we're going to generate a sinusoidal regression model. So I have these notes here on the top of page 54. So I've already input my data into L1, L2. I'm going to hit stat. I'm going to go over to the right to calc, and I like to go up, and we're going to go up to sinusoidal regression. Don't worry about iterations there, but make sure your X list, Y list are the lists you put your data into. We'd love to store a regression equation into Y1. Again, that was alpha trace enter. And we're going to hit calculate here. And it's going to quickly calculate the equation for us. We're going to write it down together. So it's going to be Y equals A, which is 113. And we're just going to go about 3 decimal places, 0.259, times sine of B, which is 0.01. Let's go 6, 8, a couple more decimal places. That's pretty important on B to be pretty specific. And then we multiply that by X, and we're going to add C. C is negative 1.319, and close parentheses, and we're going to add to it D, 727.37. Let's round that 0 up to a 1. That's our equation, and we stored that into Y1, so when we hit graph again, we will see something like this. There is probably something wrong here. We need to make sure that we are in mode. We are not in degree, as my calculator is in degree. We need to make sure we are in radian mode, which is the default setting. So you can hit mode and just go down a couple to radian, and when I re-hit that graph, now we have a good looking model. Just like we saw with the logistic earlier in our e-learning, now we see a beautiful model there that fits really well. So what you can do is you can go graph all of this data onto page 58. You can graph it right there, and you can write in the calculator form of our equation that we just found and wrote down on page 54. So 58 you can graph, 59 write down the calculator form, and next video we're going to talk about how to find the max and min for Houston.